Welcome back to another construct video, and in this video we're going to be making our very own top-down racing game. So let's get started. So step one when you open up your project is you need to set the size of how big you want your racetrack to be. Now, if you've not made one before, follow along with me. I'm going to set mine to 3000 by 3000, and as you create more tracks, you'll find a size that works best for you depending on what size and shape you want your track to be. First, you're going to start with creating a background. So I'm going to go into a tile background. I'm just going to fill this in with a block color green just to represent grass and just fill my level with it. Final thing I'm going to do is I'm just going to right click and lock the sprite. This means that I can't move it now unless I right click and unlock it again. Might as well start adding our track next. So I'm going to create a new sprite. And when you're creating your new sprite, you've got an option. You can either draw your own. So first of all, resize it to 3000 by 3000 and draw your track using the paintbrush or other means. Or you can import one that already exists and then resize it, and then make sure that you're keeping the aspect ratio, you're setting it to stretched, and then the biggest part of the image, in this case the width is the biggest number, I'm going to set that to 3000, and this means that it will fill my sort of world quite nicely. Once we've got our track in place, we can lock that as well, and then we can work on some decorations. So for my decorations, I'm going to start by adding some tires. These are going to be like tire walls that I can place around the track to make it look a little bit nicer. I could also add the solid behavior to that a little bit later to actually make it a physical barrier. And I'm also going to add in a finish line. Now the finish line is purely decorative. We're going to use another means to work out if they've beat a lap or not. So again, add any decorations you want. Final thing I'm going to do is use the 3D shape tool to add some 3D walls around the edge, make it look almost like some big walls or some stands maybe, just to add a bit more life to the level. You can see that my level's coming across quite nicely. Next, we might as well add in the cars. Now we need two lots of cars. First one I'm going to add is the player. So I'm just going to import an image I've already got, but the most important thing is you rotate the image to the right. This is really important. So when you add the car behavior, it will work as intended. If you have the car facing the other way, it's going to look a bit strange and not work as you want. Next, we're going to add in the computer's car. Now, if you want to have 3 or 4 opponents, we're actually going to use the same sprite every single time. So we're only adding in one sprite, but I'm going to add in additional animations so I can change the look of what the opponent's cars look like so they're not all the same. So now we've got our track that's together. The final thing that we need to add is probably the most annoying part of this tutorial, but one that is vital. Now, a lot of racing games, the way they work is they have an invisible checkpoint system. They might have a visible checkpoint system as well, but the one that's invisible is far more detailed. We need to add that in as well. So I'm just going to create a really small sprite, just fill it in with block red, and then we're going to resize it so it's really small. I'm then going to slowly place this around the track, and I want quite a few of these. This is going to have two purposes. Purpose one, it is going to stop our player from cheating. They have to go through every checkpoint for the lap to count. Secondly, our computer's AI is going to work off this, and they're going to be basically following and going from checkpoint to checkpoint. So it's really important you've got quite a lot of these and they are accurate. So just go around and just put a small gap between them. You might want extra on a corner, and that just means that the computers will turn more smoothly around the corners. Final thing, which is just as frustrating as placing a checkpoint, is we're going to add an instance variable called checkpoint number. And we're going to start off at 0. And then what we need to do is go around every single checkpoint and number them from 0 to how many you've got. In this case, I've got 32, so I'm going to go around one at a time and number them. Take your time with this, because if you get it wrong, it's really hard to fix because you have to go through each one to work out where you've gone wrong. So make sure they're going up by 1 each time. They're in order and you've not missed any. So now our next step is to get our behaviors in. So we'll start with the walls and my tires. These are just going to have the solid behavior just to stop the car from being able to go through them. Makes a lot of sense and really quick and easy to implement. We'll then move on to our computer. Computer needs two different behaviors. The first one is going to be the car behavior. And there's lots of settings that you can change to control how fast the car goes for the computer. Main thing is you just need to turn off this default controls. And make sure it's done by all computers by clicking on all computers first at the side here. The second behavior that we need is the solid behavior. And this means that when we impact a computer's car, we get knocked back as opposed to just going through them like they're a ghost. Finally, we go into our behaviors. We need two. First one that we need is the scroll to behavior. This means the camera will follow us around the screen as we go around the track. And then we need the car behavior also. Again, we can edit our properties. Default controls will need to be on for us. We'll start with our player first in terms of the next step, and we need to add in some instant variables. Now, there's just two that I want to focus on for now, but we will need to add more to our player later, and it's going to be the lap counts, which will start at lap 1. And then our second one that we need is going to be our checkpoint. It's going to keep track of which checkpoint that we're on. This can start from 0, and then as we move around the track, this will go up, and this will detect, have we done all the checkpoints needed to move on to the next lap. Moving on to our event sheet then, we can add a new event. I'm just going to start by checking if our player is overlapping our checkpoint. Now, we need to do this quite a few times. The first one we're actually going to do is check for a new lap. So in order to do this, we need to find out one bit of information. We need to find out what the last checkpoint number is. In this case, it's 32 for me. You might have a different number. And all I'm going to do is check if my player compare instant variable is at checkpoint number 32. Have they reached the 32nd or the last checkpoint? We also want to check if the checkpoint that they're overlapping has got a checkpoint of 0. So just to give you a bit of context, we've got our player. He's just gone through checkpoint 32. Has he now overlapped checkpoint 0 while still having the value 32? This means that he's finished the lap, and we can increase that lap count. So we're going to do two things. We're first going to take our player, and we're going to set the value of checkpoint to 1. This just means that you cannot gain more than one lap. It will change that to 1, which will stop this code from working, which means you cannot gain infinite laps. You'd have to go around the track again to get another lap. We're then also just going to add to the lap count by 1. While we're here, we might as well display the lap count. For this, we need a HUD, so we're just going to insert a layer above our layer that we've got already. Call this HUD, and then the most important thing is when on the HUD layer, change this parallax from 0x0 or 0 times 0. And this means that everything that we do inside this square box here will always remain on screen at all times. Now, there's nothing that I need to do because I've got a 3D shape here, this one here. All I need to do is make sure that it's set to render mode 2D, and this means it will draw over the 3D object. So I'm going to lock my game, and I'm going to go to text, and I want something to display the lap count. So I'll place it here. I'm going to place it in the top corner. I'm going to resize it to about 30 pixels, make it nice and big so we can see it. I also want to change the alignment to the right. And I like to write what I'd expect to see, just so I get a really clear idea when I'm going back and forth between the event sheet and the editor. So lap 1 of 3, that's how I'd want it to be displayed. So now every time we add 1 to lap, we can take that lap count and we can set the text. And just like I did lap, and then I want a space, an and sign. I then want player dot lap, then an and sign /3. So now I've got my laps in place. However, this code won't work because I'd never reach checkpoint 32. So let's deal with increasing our checkpoints one at a time. So we're going to check if player is overlapping the checkpoint. I'm going to add another condition, and we're going to say checkpoint compare instance variables and check if that checkpoint number equals the player's current checkpoint plus 1. So if they're checkpoint 2, the next one they should be going for is checkpoint 3. If they're not, it means they've gone way off the track or they're trying to take a shortcut that doesn't exist. If this is the case, we're going to take our player and we're just going to set the value of checkpoint to checkpoint dot checkpoint number. So if they go for a checkpoint number 3, they get the value number 3. but only if they're currently on checkpoint number 2. So a really good system to stop any cheating from happening. And that's it for our player for now, but I am going to add one more feature in. So what I'm going to do is I'm actually going to grab a keyboard. I've got one already, but if you haven't imported the keyboard, just add a new object and find a keyboard. And we're going to add a restart function. On key pressed, and we're going to check for the R key as a restart. And what we want to do is restart the player's position from the last checkpoint they were at. And we're going to have a big thing that displays on screen if they happen to miss a checkpoint. So we're going to add another condition, checkpoint, and we're going to compare instance variable. And we're just going to see the checkpoint that matches the player's current checkpoint, because that's the one we want to send them back. So if they've just gone through checkpoint 3 and then they get lost, we want to put them back to checkpoint number 3. So first thing I'm going to do is take the player and set their position to checkpoint.x, checkpoint.y. We're then going to do something a little bit more clever as well. We're going to add in a blank sub-event, and on this event here, I'm going to start by going to a system check and do pick all. We want to pick all checkpoints. Currently, we've only selected one checkpoint. From all of the checkpoints we've got, we only want the one that matches the checkpoint number. Pick all will refresh that, so now we can choose from all of them again, and then we're able to filter back down to the one we want, and the one that we want is checkpoint, compare instance variable, and this is going to be the player's checkpoints plus 1. So this will allow us to look for the next checkpoint, and then we can use this to take the player and set their angle towards this new checkpoint. This means when we're resetting, we're not facing backwards, we're always resetting and facing towards the next checkpoint that we need to get to. I mentioned as well about having text that flashes up if they've gone off the track or gone the wrong way. So let's implement that now. So we're going to insert a new object and grab text and call this missed checkpoint. And click. Make sure you're still on your HUD layer. And then we're going to write the text that we want to display. So missed checkpoint, press R to reset. And then I'm just going to up the size of this to 30. I'm going to align it to the center and then resize it to display how I want it to display. So actually I think it displays pretty well in the center like so. And then finally I'm just going to make it initially visible, take that off so it starts invisible. Now I'm going to set up why we want that to trigger and show and why we wouldn't want that to show. So we're going to take this line of code here that sets our checkpoint to the checkpoint number. And what we're going to do is take this missed checkpoint, scroll down and set it from visible to invisible. So go for a checkpoint. We want to make this text invisible because we've gone through the correct checkpoint. We also want to do a check if we've gone through the wrong checkpoint. So we're just going to copy and paste this block of code. But we're going to do a couple of changes. First of all, we're going to make this not equal to, and we're going to get rid of this +1. This just allows us to check if we're at the right checkpoint or not. Another issue that I've had with this is it repeats after you've gone for a checkpoint and it breaks it. So to fix this, just do this trigger once while true, and that fixes it. And then finally, we can get rid of this line of code and flip this from invisible to visible. We can also use this invisibility of the missed checkpoint when we restart. So the moment that you restart, that text disappears. You don't need to wait until you go into the next checkpoint. So let's do our first test now of this code. So as I move through the level, it is racking up my checkpoint numbers. If I decide to go off the track and try and skip, it will tell me that I've missed the checkpoint. Now I'm going to purposely face over this way, but when I restart, it will actually reset me into where the next checkpoint is. There's a really, really nice mechanic to help get the player around. And you see it's a little bit sensitive sometimes, so if I skim over and grab a bit of an extra checkpoint there, because some of my checkpoints overlap, you might see it appear. But on the whole, it's a really, really nice system, works really, really well. And if we get to the end of this lap, we'll go on to lap number 2. So that's our player in place. And the final thing I'm just going to do is just add a comment to say player, which I'm going to move up to the top. Let's move to our computer now. So first thing we need to do with our computer, just like before, is add some instance variables. We're going to start with the ones we've done already. So this is checkpoints. We've also got the lap count because we want to see what lap the computer are on, just to keep track of if we're in front of them or have they overlapped us or not. And then we also need to add in a new variable called angle direction. And this is going to be a really, really useful thing to allow us to turn the car in a smooth motion. So we'll start with a code comment that says computer, and let's start adding the computer's behavior. First thing that we've got to do is just add an event, scroll down, and we're just going to use this for each. And this will allow us to go through each of the computer's cars, one at a time. Next, we're going to click on the side here and add a sub-event. We're going to go to our checkpoint, and we're going to compare instance variable, the checkpoint number, and then we're going to do the computers dot checkpoint plus 1. This will get the checkpoint of the next checkpoint the computer needs to go to. So we're going to do a couple of things with this. First of all, we're going to get the computer and we're going to simulate control. I'm going to get them to accelerate, so they're always moving forwards. Next, we're going to go to our computer and we're going to set the value of one of our instance variables, being the angle direction. I'm going to work out this by doing angle, and then this takes in 4 parameters. So we're going to take computer X, comma, computer Y, comma, checkpoint.x, comma, checkpoint.y. So this is now getting the angle that we need to do to get to the next checkpoint. We're going to take our computer then, and then we're going to set the angle. This is going to be angle lerp, computer dot car behavior dot moving angle, then the computer's car, then the car behavior dot moving angle, then a comma, computer, and then we're going to take that angle direction that we've worked out already, comma, and then dt times 6, and then just close the bracket. I'm not going to go into too much detail about what all that means, but essentially that will just, instead of just turning our car straight to that angle, it will do a smooth transition to that angle instead. So that gets our car moving towards the next checkpoint. We also need to make sure that the checkpoints go up when they reach it, just like we did with the player. This is even more important for the computer, as if that doesn't go up, it doesn't know how to get to the next checkpoint. So next we're going to right click and insert below, and we're going to check if the computer is overlapping a checkpoint. If that's the case, all we're going to do is take the computer and we're going to set the value of checkpoint to checkpoint dot checkpoint number. Unlike our player, we don't really need to do a check to check for anti-cheating because the computer will only go towards the next checkpoint anyway. What we do want to do is actually check that the player is going for the next lap, and we can actually make our lives really easy. We're going to take this line that we've got from the player, copy it, and then paste it underneath. While it's highlighted, we're going to right click, replace object, and replace the player with the computer. And this does everything that we need it to do. And all we need to do is just delete the lap count because we don't need it. And that's our computer in place. However, there is one issue that I want to show you, and we're going to implement a fix for it as well. Now, you'll see that the computers will bash against each other a little bit, but that's absolutely fine. But you'll see that they follow a very, very straight path, and they look very robotic. And this is because they're always going to the center of every checkpoint each time, which means if you were to implement 10 computers, they'll all follow the same racing line every single time. And that's not interesting. So let's make it a little bit more interesting. We're going to go to our computer, edit instance variables, and we're going to add in a random offset. We'll set it to 0. I'm going to add an instance variable, and we're going to implement a random offset. And it will start at 0, but what we're going to do is any time that we're overlapping a checkpoint, we're going to right click and we're going to add in a blank sub-event. Now for this blank sub-event, it's just going to have one action, and it's going to be trigger once while true. Just to say that this only happens the first time you overlap the checkpoint, and then once you leave the checkpoint and go into another checkpoint, then it'll activate again, but it won't activate loads and loads of times while you're overlapping the checkpoint. Then I'm going to add an action to this, and it's going to be really, really simple. We're going to take the computer, and we're going to set the value of random offset, and then we're going to do random, and I'm going to do between -50 and 50, but you might want to adjust this. So this gives us a random number between -50 and 50. So what? What we're going to do with it? Well, at the moment we're setting the angle towards computer X, computer Y, checkpoint X, checkpoint Y. We're going to take this checkpoint X and Y, and we're going to add computer.random offset. So this will take this random offset into consideration. We'll do the same for the Y, so computer.random offset, and it's going to go towards the center. It might go 50 pixels off the center. It might go -20 pixels off the center. And this just means that the cars will move a little bit more organically than what they've been doing so far. And what I've just done is I've just increased the camera size, and you can see as the cars move around, they've got a bit more organicness to them, that move around in these straight lines anymore. So that random offset makes such a big difference. And again, it's currently set to 50 -50, but you could increase this number if you wanted this to be a bit more extreme. Bear in mind, if you go too big, you could risk the cars going off the track. So they're numbers you can play around with. Just a quick editor comment, just notice there's a bit of a bug when testing out the code right near the end. Just make sure that this line of code happens before this one here. If not, we change the checkpoint value before we update the laps, and you'd never get the compute to go past lap number 1. So just a quick fix there. So final thing we're going to do is we want to check what position the player's in. Are they in first, second, or third in this case? Because we've only got 3 cars. So for all this code, I'm just going to put it into a new code comment below, and I'm just going to call this position. And there's a couple of things that I need for this. So I'm going to scroll near the top, right click, and I'm going to start by adding 2 global variables. First one I need to do is have the number of cars in the race, so I know how many different positions that are available. There's 3 cars, there's us, and 2 computers. Move that to the top. I'm then going to copy and paste this, and I want player's position stored as another global variable. Now we can store this as an instance variable on the player, but it's more useful to have this here. So if you move to the next layout, this value be stored. So you could go to a podium and then use that value to check, are you displaying first, second, or third, for instance. Talking of instance variables, we do need 2, however, one on the computer, one on the player, and they're both going to be the same. We need one called score. So score for the computer and score for the player. We're going to be making up a mock score using lots of different bits of information that we have access to work out what position the different players are in. So first thing I'm going to do is we're going to work out this score. So we'll start by doing the computer score first, and we're just going to do it on this line of code here, because this is going every tick anyway, and we want to calculate that score every game tick. It's going to add an action, computer, and then we're going to set the value of score. Now the first part of score is really easy to calculate. So we're going to take computer.checkpoint, and then we're going to add, and inside the brackets, we're going to do 32, which is the number of checkpoints that I have, times computer.lap. So if they're on lap 2, it means they've completed 32 checkpoints twice, that's 64, plus what current checkpoint they're on the current lap as well. However, what ends up happening if you just go as far as this is if you are slightly ahead of another person, but only just slightly, you'll see your position goes from first, second, first, second, first, second, every time you go for a checkpoint. We don't want that. We want it to be as accurate as possible. So to get that little bit more accuracy, what we're going to do is we're going to surround what we've got so far in brackets, and we're going to times it by 1,000. Once we've done that, we're then going to minus, and we're going to use a formula called distance. Now, distance calculates how far away you are from a certain object. So this takes in 4 arguments. So we're going to start by taking the computer's x position, then the computer's Y position with a comma between. We're then going to take into consideration the checkpoint that they're currently looking at or going towards, and we need both the X and Y for that. So now this will work out how close we are, and the further away we are from the checkpoint, the more we're subtracting. So if you are on the same lap, on the same checkpoint, it will then take this distance in consideration to work out who's closer. So that's the computer scored worked out. We're then going to copy this just for now, and we'll move to our player. And for our player, doesn't matter where we do it, but we do need to add in another action below. I want to check the checkpoint number, compare instance variable, and this is going to be player.checkpoint plus 1. So the next checkpoint we're going to, and then paste in that value there. So this is the computer score at the moment, so we're just going to replace object with computer to player, and this changes everything inside the brackets as well, saving us doing a lot of typing there. So now we've got two scores worked out, and this will tell us who is the furthest in the race. So now we just need a small function to actually see whichever scores the highest, that's the position that the player must be in. So just need a function in place that will go through all the scores and go, okay, you've got the second highest score, so you must be in second place. So for this, we're going to add an event. And I'm going to start off by doing every tick. Now, every tick, the first thing that we're going to do is we're going to go system. I'm going to set the value of player's position, and we're going to put them at position 1. Once we've got that, we're going to right click at the side and add a sub event, system, and scroll down. We want this for each ordered. So we're going to take the computer's car and we're going to do computer.score. Once we've got that in place, we're going for another sub event. And this time, we're going to check if the computer and then compare instance variable. We want to compare the score is greater than or equal to player.score. If their score is greater, that means they're further in the race than us. So what we're going to do is we're going to do system. We're going to add to the player's position by 1. So for every single computer that's ahead of them, we're going to increase that position by 1. So if they were first, they were second, then third, then fourth, and so on. Next, we actually need to display that to the user. So we actually need to go back to our layout very, very quickly and just insert a new text box. And then we need something to hold the player's position. So position as a text box, place it somewhere. And then again, how would you want that to be displayed? So for me, I'm just going to write position and then maybe a colon 1. Change text size. And done. So position 1 in place. So final thing that we just need to do is add an action, and then we just go to position, set text, and then just write the same thing again. So position, colon, then use the and sign, and then just player's position. Now we also want to display the text if the player is in first place. So if this code doesn't activate at all. So we're just going to add in an else statement and then just copy and paste this text as well to just say display the player's position even if we've not added 1 to it. And that's it. We've got all our code in place. The only thing you might want to add in finally is just go to player and just scroll down and compare instance variable and just check maybe if they're on lap number 4. Lap number 4 means that they've finished all 3 laps, because remember you can be on lap 3 but you've still got to complete lap 3. So if they're on lap number 4, and then you can decide what to do. So you might want to go, okay, I'm going to go to the next layout where I've got a little display message that says well done, you're first. You might want to restart the level or set the timescale to 0, which will pause the game, which I'll do for my example. But we're ready to do our final test. So just do my final test here. So if I squeeze past into position number 2, and then now I'm in position number 1, and if I get to the end, I'll increase my lap as well. So Hopefully you found this video useful today, something a little bit different, and can get you start creating your first sort of mini racing games like Micro Machines. If you enjoy this sort of content, then please subscribe to the channel where you'll find a lot more of it. Like this video if you've enjoyed it, comment down below your ideas for more future videos, and I'll see you in the next one.